These are some question types you can expect to run into on your upcoming SAT. Starting with English, we've got appositive impostors. Of course, to know what the appositive impostor is, we need to first talk about what an appositive is. And in its simplest terms, an appositive will rename something or someone. For instance, this phrase, superhero and magnanimous billionaire, is renaming Batman. It's another way that we can refer to Batman. It gives us additional information about Batman. And whenever we have one of these appositives, we need 2 commas, as you can see here. So let's talk about the appositive imposter. And do yourself a favor, go ahead and pause the video and try these on your own first. But here we go. So we have something that might look like it's an appositive. If we start from Wilder's, we have Wilder's unforgettable performance as the eccentric chocolatier, a character that critic Pauline Kael wrote, and then we have a quote from Pauline Kael. So it seems like we might have an appositive, right? We have critic, and then we have Pauline Kael. So it's renaming critic. It's telling us which critic, right? So we might be thinking choice A, right? We've got these 2 commas that we need, but we would actually be wrong because this is an appositive imposter.
Don't let this imposter fool you!
It looks like an appositive, but it is not. And the way to test is to get rid of the information between the commas. So going back to Batman, we could say Batman stepped in and saved the day, no problem. But if we said Wilder's unforgettable performance as the eccentric chocolatier, a character that critic wrote, and then we go with the quote, we're going to be wondering which critic. We don't know. So this is actually essential information, which means it is not an appositive. We have to have this name because otherwise we're going to be asking ourselves which critic. And this is usually going to be the case with names. The way that we can tell is if we have some sort of description, often a title or a job that many people could have. And yes, the correct answer is going to be choice C. We would not want any punctuation if we had one of these appositive imposters. One exception to this would be if we had a title or a job that only one person has. For example, if I said the headmaster of Hogwarts, Albus Dumbledore, said I was suspended from school, this is fine because we can assume there's only one headmaster of Hogwarts at a time. So whenever I wrote this statement, we know the headmaster of Hogwarts is Albus Dumbledore. So we could definitely say, the headmaster of Hogwarts said I was suspended from school. Next up is dash sandwiches. And the dash sandwich is going to show up in this question right here. See if you can spot it and answer this on your own first. But yes, basically, we've got a dash here, and we've got a dash in answer choice C. And I'm going to say most of the time, this means you're dealing with a proper dash sandwich, and this is the correct answer. But just like on the last question, when we're omitting non-essential information, which is what this dash sandwich is, we have to test it. We have to make sure that we're allowed to get rid of it. So if I got rid of all of this stuff, including the word buzz, we would have the shimmering neon lights of Las Vegas are powered by an intricate electrical grid where energy flows through miles of transmission lines before reaching the city's casinos and landmarks to bring the strip to life every night. And as you can hear, that sounds beautiful. There's nothing wrong with it. So we do want to go ahead and choose answer choice C here. We have a proper dash sandwich. Just be careful because you can definitely start one of these non-essential sandwiches with commas as well, as we saw in the last question. The only thing is you can't mix and match. If you start with a dash, you have to end with a dash. If you start with a comma, you got to end with a comma. Next, we've got tricky punctuation questions using the word however. Here we have an example of however being used, and I want you to notice it's going to create a contrast with the sentence that came before it. We have, we would love to eat pizza for every meal, breakfast, lunch, and dinner. And then we get, a balanced diet is ultimately what we should be aiming for. Now, those are contrasting ideas. Eating the same thing for every meal is the opposite of having a balanced diet. And the word however speaks to that contrast. This is always going to be the case, and this is the main thing that you want to remember. If I had, however, here in this last sentence, this would go along with having a balanced diet, right? Diversifying our diet is the same thing as having a balanced diet. So it would not make sense to stick, however, in this third sentence. So that seems straightforward enough, but just to make things a little bit more complicated, however, is not just going to be at the beginning of a sentence. We can also stick it in the middle of a sentence. So here we have the same thing, except for we stuck it in the middle. A balanced diet, however, is ultimately what we should be aiming for. It's still contrasting with the previous sentence. That is always going to be the case. It just happens to be in the middle. The one thing we would remember is, since it's in the middle, we treat it like non-essential information. It's going to need a comma sandwich. And of course, however, can also show up at the end of a sentence, like this. There's always going to be a comma involved, but it needs to be sandwiched between either two commas, a comma, and a period, or in the case of our first one, I guess a period and a comma, right? But again, it's still going to contrast with the sentence that came before. It should always contrast with the sentence that came before. So with that in mind, pause the video, try this question on your own first, and try and figure out how we should be punctuating this based on that information. But let's go ahead and take a look here. So if we look at choice A, we are ending this phrase with however. We are ending this clause with however, which would mean it would contrast with this first sentence. So let's see if that is happening. Using underwater drones, this person studies migration patterns of deep sea fish. Belkin doesn't just collect the data, however. He also does this other stuff. So this is not quite that one-for-one contrast that we saw in the last example, but it is a contrast because we're getting some information that he studies the migration patterns. So that would be, we could assume, collecting data. But here it's saying he doesn't just collect the data. So it's a little bit of a contrast to the first sentence. So the however in that clause would make sense, and A is going to be our answer. The other possible tempting answer might be choice B, but choice B has a couple of issues with it. First of all, if we're starting a new independent clause, because a semicolon acts like a period, by the way. If we're starting a new independent clause, we need a comma after however, remember? So that's an issue. But even if we had that comma, now all of a sudden we would be contrasting the third sentence with the second sentence, which doesn't really make sense because they go together. It's saying he doesn't just collect the data, and then it's telling us how he doesn't just collect the data. So those two ideas are linked. They are not contrasting. Therefore, choice B would not work. And from that explanation, it should be pretty obvious why choices C and D are also not going to work. Next up, we've got vocabulary words that you just don't know. And I know you might be thinking, what the heck, dude? If I don't know the words, what am I supposed to do? And that's exactly what I want to talk about here. So let's just pretend that we don't know a couple of these words. Let's say I'm familiar with negating. I don't know prefiguring. I don't know entrenching. And I do know substantiating. So the two middle words I'm not familiar with. Well, first thing we always want to do with words in context is to look at the context, because we should be answering based on that context. And here we've got a meticulous reexamination of the manuscript poems and fragments, long ascribed to the Greek poet Sappho, has uncovered nuanced stylistic anomalies that deviate from her established literary conventions. That is a mouthful, so let's put that into English. We're going to say, basically, looking at this manuscript, it seems like there are some things stylistically that are going on that don't usually go on with her poetry. These irregularities indicate that certain passages may have been interpolations by later authors, potentially blank our understanding of Sappho's authorship. So it's saying that some of the poetry might have been tweaked and changed by other authors. This would change our understanding of Sappho's authorship. And what I did just then was come up with a prediction, and you should definitely be coming up with predictions for words in context questions. So we're looking for, I guess these are all going to be present continuous tense. We're going to be looking for something that basically means changing. And from here, we would start eliminating answers. Now, importantly, if you don't know a word, you should not eliminate it unless you have a good reason to do so. So if I were going through the motions here, I would say negating would be a form of changing, right? Our understanding would no longer be the understanding that it once was, right? We would negate it. So that would make sense. And it goes with changing. Again, if I don't know what prefiguring is, I would keep it. If I don't know what entrenching is, I would keep it. Now, substantiating is going to be the opposite of negating. And this is where I would recommend actually getting rid of choices B and C, because more often than not, in the answer choices, you're going to have your correct answer, in this case, negating, and you're going to have the opposite of the right answer, in this case, substantiating. And they're not perfect opposites, but you can see how they're sort of antonyms of each other. And if you have two answers that you don't know, but you notice that the two answers you do know are opposites, go ahead and get rid of the ones that you don't know. Again, because more often than not, you're going to have an antonym along with your correct answer. And just like that, we can confidently go with negating. Our next question type is modifiers. And modifiers are some of the strangest questions on the SAT. And a lot of my students just don't even know that they're a thing. So let's talk about what they are real quick. The rule is going to be whatever or whoever is described before the comma must come right after the comma. For example, this sentence would not work. We have eager to impress his boss at the annual company picnic. Dave's unfortunate decision was to showcase his juggling skills. The problem is, who was eager to impress his boss at the annual picnic? Dave was, which means Dave needs to come right after the comma. And I know what you're thinking. What the heck, man? Dave does come right after the comma, right? No, there's an apostrophe here, meaning that the actual main subject is going to be his unfortunate decision. His decision was not eager to impress his boss. So for that reason, this sentence would actually not work. We would want something more like this. Eager to impress his boss at the annual company picnic, Dave made the unfortunate decision to showcase his juggling skills. So we actually need Dave right there, right? And that's it. That's the rule. Whatever or whoever is described before the comma must come right after the comma. So pause the video and try this one on your own first. But here we go. In discussing the architectural achievements of Antoni Gaudi. So a little trick that I like to do is to sort of make a sentence with the answers. Since we have discussing, I'm going to say was discussing the achievements or were discussing the achievements. So for choice A, we would have many scholars were discussing the architectural achievements. That would work, right? It makes sense that people would be discussing achievements. Choice B, Gaudi's designs were discussing the architectural achievements. That does not work. Designs can't talk, so they certainly can't discuss. B does not work. C, there were discussing. So existential there is definitely not going to work because, again, we need people discussing. Many scholars' emphasis was discussing the architectural achievements. So again, we have that apostrophe, which means it's not the scholars which are doing the discussing, it's the emphasis that is doing the discussing. And an emphasis certainly can't discuss anything because, again, it's not a person. So just from that alone, we've got choice A as our answer. And we really didn't even have to look at the rest of this, right? Pretty cool stuff. Now, those were just a couple of the strategies from my English courses, both of which usually sell for $50 a piece. But if you use the link in the description, I'm going to give you both courses for $50. So that's 50% off if you buy them together. And I'm going to throw in my new Expression of Ideas course, which will be launching before the May SAT. Just use the link in the description in the next 2 weeks and you'll get 50% off. All right, moving on to the math section, we've got special right triangles. And luckily, you are going to get this image in your reference sheet on Blue Book. So you don't have to memorize this, but just remember to actually pull up the rules and look at this if you notice you're running into these questions. What I would memorize is these numbers. If you see 45, 45, 90, if you see 30, 60, 90, go ahead and pull up your reference sheet so that you know what to do. But these are going to be the rules. And let me just kind of show you what this looks like, right? Here we have a 90-degree angle. We also see that this is 45 degrees. Because a triangle can only have 180 degrees, this has to also be 45. So we know we've got a 45, 45, 90. Let's say we're solving for x. So we know from our little image here that we have a side, we have an even side, so we could say this is x as well, and we have the length of one of those sides times the square root of 2. In this case, they tell us that the hypotenuse is 7. So we could say 7 equals x times the square root of 2. And we're trying to solve for x, right? So now it's as simple as getting x by itself. Divide by the square root of 2, we get 7 over the square root of 2 equals x. One thing though, in your answer choices, you're probably not going to see this because math folks don't like square roots in the denominator. I'm not sure why, but they don't like it. So we have to convert this. We would have 7 over root 2. And what we can do is we can multiply by the square root of 2 divided by the square root of 2. The reason we're allowed to do this because anything divided by itself is just 1. And then it rewrites as 7 root 2 divided by square root of 2 times the square root of 2 would just be 2. And that's the answer that you would be seeing in the answer choices. So quick example of how to apply this right here. With that in mind, go ahead and pause the video and try this question. But here we go. So it's telling us that ABC is an equilateral triangle, and we can already kind of see that, right? We see that these guys are 20. We see that this is 20 because we have 10 and 10. Equilateral meaning all of the sides are the same and all of the angles are the same. In this case, they were also kind enough to include the 30 and the 60, but we should already know that we're dealing with a 30, 60, 90 anytime we cut an equilateral triangle in half. It is asking us what the value of AD is. Where is AD? It's actually this line down the middle. So 30, 60, 90, that means we have x here. We have 2x here, and we can see that's true, right? 10. 10 times 2 is 20, which means that this side right here is going to be 10 times the square root of 3, according to our little cheat sheet here, right? So just like that, our answer is choice A. Up next, we've got linear equations with no solutions or infinite solutions. And the thing that we need to remember about no solutions and infinite solutions, as long as we're dealing with, a linear systems or a linear equivalent expressions, is that they both are going to have the same slope. And I might as well just show you on Desmos real quick. So let's say we have y equals 3x plus 4. I'm just pulling that out of nowhere. No solutions would be the same slope, right? Y equals 3x, same slope, slope being 3. And then we'll give a different y-intercept. As you can see, these guys are parallel. They're never going to touch. They're never going to have any solutions because a solution is when they're touching, right? But if I said 3x plus 4, the same exact equation, now they are overlapping each other. They have infinite solutions. They are equal to each other. So yes, we have the same y-intercept this time, but we still have the same slope. So it's easy to remember that regardless, you can look for the same slope if it says infinite or if it says no solutions. So here we have a constant, right? It's saying mx plus 43 equals 7x plus 14. Now, if this expression has no solutions, we don't care about the 43 and the 14 because they're never going to be equal. But we know automatically that m must equal 7 in order for them to have the same slope. All right? So try this question on your own with that in mind. But here we go. For this, again, it says no solution, so I really do not care about this stuff. And even if it was infinite solutions, I probably still wouldn't care because I'm just looking at the slope, right? So all I care about is this, 5mx equals this, 45x over 19. I don't like having x and m here, so I'm going to divide the whole thing by x to get rid of it. And now 5m equals 45 over 19. So we just have to divide both sides by 5 in order to get m by itself. Now we could multiply by the reciprocal. We could multiply by 1 over 5, or we can just plug this into Desmos and make it easy on ourselves. So I'm going to plug this into Desmos real quick. Again, we're doing 45 over 19, and I can highlight that whole thing divided by 5. Alternatively, I could do 45 over 19 times the reciprocal, 1 over 5, you're going to get the same answer, right? And this is terrible, and we could definitely write 0.47, but it probably feels better to just write the fraction. So if you click this little button right here, you get your fraction, and our answer is going to be 9 over 19. And again, that comes from just focusing on the slope. Our next problem type is exponential equations. These guys can get a little bit more complicated than this, but in essence, this is what you want to focus on. You're going to have your total on the left side of the equation. After that, you're going to have your starting value. After that, in parentheses, and this is oftentimes one of the most important things to focus on, is going to be an increase in percent or a decrease in percent. And then finally, your exponent is some amount of time. And this should help you handle most exponential equations on the SAT. There are some more complicated variations, but once you get used to this one, you should be able to learn those with relative ease. So keep this in mind, rewind and go back to it if you have to, but pause the video and try this question based on what you just learned. All right, so here, I'm going to skip to the main question because I don't like reading, and it says, which of the following best models the thing that we're talking about, right? So basically, I'm just choosing an equation that goes along with whatever they're saying. And I'm already noticing that the only difference in all these answer choices is my percent increase or percent decrease. So if I just find out what that is, I'm good to go. It says we're increasing each year by 10%. Importantly, if we increase by 10%, we're going to multiply by 1.10. The reason being is that we have our original 100% plus the additional 10%. So no, it would not be choice A. It would be choice C. All right, next up, we've got these tricky systems of equations word problems where you think you're answering one thing, but you're actually answering another. Let me show you what I'm talking about. So here we have a system of equations, and it's pretty easy to tell that you have a system of equations because we have two different types of things and we have different values associated with those two things. In case you're not familiar, this is the most common type of systems of equations that we're going to run into, is basically two linear equations in standard form. So we've got our items, x and y, and we have our associated values, a and b, and then c is going to be a total. And it could be a total value, or it could be a total number of items. So here, we could set this up as a value plus value equals value. We know that we've got $10 for general tickets, we'll call general tickets X, plus $6 for student tickets, we'll call those Y, equals, and since we can see the value, the 10 and the 6, it's going to be value plus value equals value. And they give us the total value of 340. And then our other equation is going to be items, which are tickets. So all of the general tickets, X, plus all of the student tickets, Y, is going to equal the total number of tickets, 40. And that's our system of equations. At this point, I would recommend just plugging this into Desmos. So let's go ahead and do that real quick. And it looks like we're going to have to back off a bit to find our intersection, but there it is, 25, 15. So 25 is X, 15 is Y. Now let's go back to our question. What were they asking about, X or Y? Well, it said how many dollars were collected from the sale of general tickets. general tickets being X. So if X was 25, which it was, remember we looked at Desmos, X is 25, then we might be thinking our answer is 25. But this is where it gets tricky. You need to make sure that you are answering for the correct thing, either value or items. 25 is the correct answer for items. That's going to be the number of general tickets. But it's not asking about the number of general tickets. It's asking about the dollars collected from general tickets. So we have to take that 25 and multiply it by its assigned value, 10. So our answer is actually going to be 250. Our last question type is upsetting constants questions. For example, this might look like a little bit of a nightmare to some of you guys. We've got this polynomial with stuff moving up to the third degree. We've got A and B. They are asking us the value of A and B multiplied by each other. What the heck's going on here, right? Well, the good news is with these equivalent expressions questions, we really just have to focus on like terms. So looking at this, for example, we have wx squared plus tx squared plus f equals 3x squared plus 8x plus 11. And our like terms are going to be determined by if they're being multiplied by x squared, by x, or by nothing. So on the right side, the only thing being multiplied by x squared is 3. So 3 has to equal w because those like terms are always going to be equal to each other. Likewise, t is going to be 8, f is going to be 11. And in a nutshell, that's really all we need to focus on for these particular type of constant questions. So pause the video and try this on your own first, but here we go. So in this case, they're asking about the value of A, B. Now, you could say, well, I want to focus on A and I'll find out what it is. And then I'll focus on B and I'll find out what that is. And then I'll multiply and then I got my answer. But there's a shortcut. Here, they're asking about AB. So let's actually focus on AB. As we FOIL the left side out, the only time that we're going to get AB is when we multiply AX times negative BX, and we're going to get negative ABX squared. So now I know I only have to focus on things being multiplied by x squared. Those are my like terms. So on the right side of the equation, this is going to be equal to negative 7x squared. And you might be thinking, all right, we're all done. We've got it. We're good. But you would run into an issue because these are not all of the x squareds. We're forgetting about 4x squared times 2 on the left side, which would be 8x squared. Now they're all accounted for. So what we can do from here is subtract 8x squared. Well, actually, let's get rid of the x squareds first because those are annoying. We could subtract the 8. Over here, we get negative 15. If negative AB equals negative 15, then positive AB equals positive 15, and our answer is choice C, 15. Now, that's the first strategy for constants questions, but there are actually 5 more that you're going to want to learn from this video right here. And according to students I've spoken with, constants questions were all over the March SAT, so you're not going to want to skip out on this.
Boom, 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 boom.